So the first part of this exercise is creating a network dataset in ArcGIS Pro. And to do so requires a number of steps because the quality of network routing results are completely based on how well your network dataset is built. So the first thing we do is, and I'll go over here to ArcGIS Pro, which I have open. First thing you want to do is just go to Project and make sure you have the Network Analyst licensing active. So you just scroll down in the list to Network Analyst and make sure it says a yes. If not, then enable that extension. Next, in my exercise 7 data, I'm going to do the driving folder and then the network GDB dataset. And we'll first have a quick look at the geometry that will be participating in the driving network that we're going to create. So I'll just bring that in temporarily. It's called CAN RTE. And so it looks like that. And it has all the road segments in Ottawa. If I was to click on one just to identify it, up will come the identify dialog box showing the attributes, if I can get to it there. There we go, eventually pops up. And that road segment, for example, again, I'll just show you where that is by quickly flashing it right there. So that road segment has a number of different things. It has the name of the road. It has the address ranges of the road. These are important if you were to do address-based geocoding, such as you learned in the Introduction to Geomatics course. And as we scroll down, we have other things in here. We have the from node and to node, nothing to worry about, but we have speed in kilometers per hour, very useful. We have the road length in meters, so how many meters that particular segment consists of. And then we have from minutes and to from minutes. So from 2 minutes and to from minutes. And these represent how long it takes to traverse in one direction or the other, that particular segment. So 0.494 minutes at 40 kilometers per hour, which is the speed limit. Then we have FZLEV, that's from Z elevation to Z elevation. Elevations are really important in creating network data sets because without elevations, we would have the ability to change direction wherever there was an overpass on a street. For example, if we just zoom out here and we go to the 417, there's a number of streets here, let's say like Lion Street, or even better, here's one, Percy Street. So Percy Street actually has no access to the 417. And so an elevation field in a network data set tells the network solver that the Queensway here, the 417, is above Percy Street. And that way, if you were to travel from this point here on Percy Street to this point here, you wouldn't end up changing direction and going onto the 417. Or if you're on the 417 and you want to go to Percy Street here, you wouldn't be able to get off right here and go to Percy Street because there's no cloverleaf, there's no access there. And that's what the elevation fields tell the network solver, is that you can't just change direction whenever you find a given intersection, like we see here for Percy Street. So here you can see clearly that even though Percy Street has a line that goes, looks like it goes through the 417, you can't actually, it's actually going under, because you can see the 417 is above Percy Street, and you can even see the shadow there from the sun. So obviously, if somebody wanted to get from the 417 to Percy Street, they couldn't just turn right, let's say, on this line, because it's not really crossing, it's not intersecting, it's underneath that overpass. So let's just go out back here to our identify box, just see the attributes. So that's what the elevation fields tell, the FZLF and TZLF, so from and to, 0 and 1, so that is telling us about the elevations. We have other things in here as well. We have hierarchy. So hierarchy is a preferred road selection. So roads can be hierarchically organized into preferred roads versus non-preferred roads. For example, highways being strongly preferred over back streets. And all this can be integrated into the solver for the network analysis. And we'll see how. So I'm going to remove CAN RTE from my map and remove CAN RTE, as I said. So you must remove it before creating the network data set. So it's not in your map, just like that. Then we go back to the driving feature data set. And in here, we have no network data set yet. So we have to create one by simply right-clicking on driving and saying new network data set. And here, it'll give us a opportunity to give this a name, and we'll call this the driving underscore ND for network data set. And then we choose what feature classes are going to participate in this particular network data set. And as we saw, we're going to be using the CAN RTE. So I'll just put a check mark beside that. And we do have elevation fields, as you saw, so we want to make sure that we're modeling elevation. And we'll click run, and this will create the blank network data set, which we will then customize. And then it gives the create network data set dialog, network analyst tools, with the check mark and everything, saying that that was successful. Now I'm going to go up to catalog, and I'll see in my driving feature data set, if I just right click, I can also do a refresh if you don't see that, but you should see a driving ND. And it has a little icon that shows a grid with a line through it, a red line. That's a network data set. Now we have to set that up. So we right click and say properties. By default, in the general tab we'll start with, or the general item on the left-hand part of the pane there. It'll say network data set, gives us information where this is. Build status is not built. So a network data set, once created, must be built once you've set it up. And that's where all of the topological tables are created that help the algorithms solve network routing problems. So scrolling down a bit more, we want to just click on indexes. If it's closed, open it and say service area index. That just makes it quicker for creating what are called service areas, which you'll or have learned about in the module. So that's the first step here. Next, I'm going to go down to source settings first. So we want to set our vertical connectivity here as our elevation fields. Very important. So this is from node. So I'm going to take FZ11, I should say. So from Z11 and then to Z11 will be the TZ11. Ooh, not that one. TZ11 like that. Group connectivity, we don't have to worry about because we only have one feature class participating in the network. If it was a multimodal network, that means we have, let's say, walking networks, sidewalk network, pathways, shared pathways. Well, we would have to say how they connect to each other in the connectivity group, but this is a simple driving network. So going back to vertical connectivity, we've set that up. Then we'll go down to travel attributes. Back in travel attributes now, in the travel modes tab, we want to add a travel mode. So I click on the little hamburger menu here and I click new, and it will give us the name called new travel mode. And the type by default is driving. The impedance is length by default. And so next we'll click on costs and it will say length here now by default. And all we want to do here is to go down and make sure it says field script shape, and same as the long shape. And that means it's taking the geometry and calculating the lengths and stuff from the geometry of the particular feature class. What we want to do is add a second cost for minutes or time. So we'll say new, and then by default, I'll say new cost, and I'll call it travel time. Just all one word, just to make it easy. Units will be minutes, and the data type will be double by default. And then we have to set down here where that information comes from. So we want to choose at the bottom right here, field script, and then another one, same thing here, field script. And then beside field script in the value column, we click on that. You can double click if you're fast. If you don't get anything's happening when you double click, just click until you see the little function button on the right hand side and click on that. And then we change the language at the top to Python, and the result here will be a long, so that'll be, we'll call that the from 2 minutes. So remember the field, there's a field called FT minutes, and it has to be spelled correctly. It's all capital. And in Python, of course, for the field names, they have to have the exclamation marks, FT minutes. And then for the second one, right underneath, against will be TF minutes. So in result, again, exclamation mark, TF minutes, like that. And again, those are coming right from the attribute table. So now we have a travel time restriction as well on our network, and that travel time will be in minutes. We'll add one more restriction for one-way streets. So I'll say new. This will be, I'll just call it one way. One way like that. It will be, again, in minutes. And this time, when we go down to can route along, same as default, we want to choose that to a field script. And then in the value, again, I want to open that up and go to the editor. I'm going to choose Python as the script language. This is where you might, if you ever forget to put Python, you'll get an error because we're doing everything in Python, obviously. And I'm just going to make a thing here called restricted. And it's going to use what's called a Python function in the code block. So I'll say def restricted, which is the name of the function. So I'm defining a function restricted that takes in a specific column called one way from the attribute table. And so I just say X equals one way here. And then I have to indent the next lines because this is a function. So everything under has to be indented. So once you have a colon, anything under that has to be indented in Python. And I'll say if X in this list of N TF or T, then, so I put another colon, and I have to then indent everything under there. I'll say return true. And then I'll have this, and then I'll say else colon, and then double tab again, return false. And I won't go into the details of this, but basically it looks at the one-way field. So whenever the solver is looking at a particular segment, that segment, it looks for these values in the one-way field. And if any of those values are there, then it's a one-way street, so it returns true. And the solver then takes that into account. Otherwise, it's not a one-way street, so it returns false. And so the one-way restrictions can be ignored by the solver. So I click OK here. And you'll see it says script and then script. It's the same for both of them, whether it's to or from or to. Either could be one way. So now in cost, we have one way, we have travel time, and we also have length, the default. And for we'll go back to the minutes here, or travel time. And under turns, I just want to change that to turn category instead of constant. And then on right here, default 0 second, turn category 5. I want to go and click on the little function button there. It's going to open up a little pop-up window. And I want to give for left turns 5 seconds. So that's a 5-second delay for left turn. And for U-turn as well, 5. Like so, and I click OK. And then we'll go to the next step. So the next step is restrictions. So in the restrictions, I want to put a new one. New. It says new restriction. Then I'll click on the new restriction here. And I want to change these can route along and against to one way for both of them. So I have to say that's a field script. And that one also, I'll just leave that, it'll take it up by itself. And then I go over here again, get that open thing, change it to Python. The result will just be one way. Like so. And I'll click OK. That'll automatically fill in the against as well. Just have that restriction in there. Then we're going to click on the hierarchy tab and add hierarchy. Click on the button. And again here, we're going to have for our long and against a field script. And that's just going to be specified as the field hierarchy. So exclamation mark H. How do I spell hierarchy again? HIERARCHY. Like so, hierarchy. And that'll go into both of them. So next, we'll just review all the things that we have. So in general, we have everything here. We made sure to click on service area index, source settings. Our sources are here, and then we clicked on vertical connectivity to set the elevation fields. Travel attributes, we started with travel modes, and we have a driving by default. So our network is about driving. Its default impedance or restriction will be length. And then we added costs. So the cost of traveling along a network edge. First we added travel time. And there was from 2 minutes and to from minutes because they are fields in the table. We need that data to have that travel time. Or we can create that ourselves by assuming the speed limit and the length of the roads and using the simple equation speed equals distance over time to figure out any of those 3 variables and adding them to our attribute table if we don't have them. We then also put a one-way for costs. In there we have a script. Then we went to restrictions. We have the one-way restriction in here again as a restriction. And then we went to hierarchy. And we modified the hierarchy. We didn't look at descriptors. You can read about them. And time zones. These are mainly important for if you want to have, if you're moving a large fleet across the country, you could add time zone, for example. But we don't have any tables for the time zone to use that with. That being said, we reviewed things, so we click OK. Oh, and it gives us a syntax error. It says attribute hierarchy source FDL field syntax error line 1 character 58. So it's telling us that something's wrong with the hierarchy. So let's have a look at that. Hierarchy. It's telling us that there's something wrong here. So I'm going to look at that one. Oh, and I have VB script and I'm using Python. So I have to change that to Python. And I click OK. And then that next one will automatically take that up. So that's the most common thing you're going to see come up as an error, something like that. And then you have to look at your, wherever you used a field script and make sure that you set it to Python, since we're using Python code. So I'll click OK again, and nothing happens. It just goes away. And we go back now to our driving feature data set and the driving network ND. We right click on it and we say build. And it will ask us to build the network, and we click run. Now it creates all of the topological tables and everything that it uses for the algorithms to solve network-based issues or travel along a network. And that can take a few seconds to a few minutes, depending on the size of the network. And so it's now built. The next thing we want to do is just have a quick look at how our network is working. So that means that every road, if I choose a road in here, I'll just zoom in, like this road here, should be connected to the roads around it. And if I click on Network Analyst up here for network, there's a little Explore Network tool. So to explore our network, what we want to do is click on Analysis to make sure we have connectivity correctly. And then I'll say Network Analysis, and I'll just choose Route to start with. That'll add a route analysis layer, which will allow me to use just a quick network exploration tool to assess whether I have connectivity the way I would expect it to. So that means, for example, that this street here called Glunney Street should be connected to Alta Vista, and it should be connected to Lenox Park Avenue right here. So I click back on my driving network ND, and I click on the network up here if you have this tool, and I click Explore Network, and I'll just click on Glunney Street, for example. And it shows me the connectivity, whereby somebody can get off this street, go on that street to that street. If I click on one of the other streets here, then that connectivity is all the way to those things. And so it's just a quick way to check connectivity, ad hoc means of validation, just to see that you do have the connectivity you might expect in the network, because every segment should be connected to its surrounding segments or ones that are touching it, like so.